Okay, in this video, we're going to look at a couple of approaches for working with some past AP statistics exam questions. Right? In particular, we're going to talk about working with distributions. So our setup here is that we have grocery stores purchase melons from two distributors, J and K. Distributor J provides melons that are grown using organic methods. The distribution of the diameters of the organic melons from distributor J is approximately normal, with mean 133 millimeters and standard deviation 5 millimeters. All right, so it is important to note that we are approximately normal. Okay. Now, for a melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137 millimeters? Right. Well, if you'd like, pause the recording for a moment and then unpause and check your work. So it's very important to make note of the information, and that is that X is normally distributed. We're going to have a random variable representing our melon from distributor J. Randomly distributed, normally distributed, mu 133, sigma equals 5. Be clear. And we're trying to find the probability that X is greater than 137. Now, if you wished, you could have used J to indicate distributor J. Right? The variable doesn't matter as long as it's not misinterpreted for something else. But we know that if we're going to get full credit, we need to not just say what is it in terms of X, we need to normalize and standardize our variable and get that Z-score. So greater than 137 is the same as being, right, and this should be greater than 0.8. We want to be careful on our notation. And that's going to be 1 minus 0.7881, which would be 0.2119. All right, so we want to make sure that we can write all the information down correctly. And you have a calculator or a formula chart that can help you with that. Okay. Now, distributor K, they provide melons from non-organic farms. The probability is 0.8413 that a melon selected at random from distributor K will have a diameter greater than 137. Right? So very likely that the diameter is going to be greater than 137. In fact, we know for sure, based on this probability, that 137 is less than the mean of the distribution. Right? Now, for all melons at the grocery store, 70% of the melons are provided by distributor J, the organic distributor, and 30% are provided by distributor K. So, for a melon selected at random from the grocery store, what is the probability that the melon will have a diameter greater than 137? Feel free to pause the video and unpause when you're ready to check your work. So for this situation, we need the probability that from J or from K, that whether it comes from distributor J or distributor K, all right, we need to know, hey, is this random melon from the grocery store coming from J or is it coming from K, so that we can figure out our probability, which means we need a weighted average essentially. So we have to figure out, well, what's the probability of being greater than 137 millimeters in diameter, given that I come from J? And what's the probability that I'm greater 137 millimeters in diameter, given that I come from K? And that way, when I multiply this conditional probability by the probability comes from J, this will give me the probability of coming from J and being greater than 137. And this will give me the probability of coming from K and being greater than 137. So this conditional probability we found in part A, 0.2119. And we know 70% are coming from J. This conditional probability was provided to us. And we know 30% come from distributor K. So multiply these two probabilities from J or from K. add them together, and I get this 0.4007. Okay. Now, our next question. Given that a melon selected at random from the grocery store has a diameter greater than 137, what is the probability that the melon will be from distributor J? So we have a conditional probability we need to find. All right, feel free to pause the video and then unpause when you're ready to check your work. Okay, so conditionally, we're saying that it's given that the diameter is greater than 137. All right, so given this, what's the probability it comes from J? Well, we know that that's going to be the probability of being from J and greater than 137 divided by the probability of being greater than 137, because we know conditional probability of A given B will be the probability of A and B divided by the probability of B. Well, what is this joint probability, J and greater than 137? Well, that's going to be greater than 137 given J times the probability that I come from J. All right, and this should be 0.2119 times, not 0.17, this should say times 0.7. Right? Want to be careful in your writing. And I have 0.2119 times 0.7 divided by the probability that I'm greater than 137, 0.4007. Right? And if I go through, I find out that this probability is 0.3701. Right? So it is going to be not uncommon to come from distributor J, but it would be much more common that it came from distributor K, even though K only represents 30% of the melons in the grocery store. Now, a store manager, right, the grocery store manager prefers large organic melons. And they randomly select melons from distributor J because distributor J has the organic melons. What is the probability an SRS of 6 organic melons chosen by the manager will have at least 2 melons with diameter greater than 135? Think about how you would set that up. Pause for a moment, go through the work, and then unpause the video when you're ready to check. So if we look at this, all right, we are going to define a new variable y, and y is going to be binomial, where I have a fixed number of trials, 6, and a fixed probability of success, 0.345. Now, where did 0.345 come from? 0.345 came from the fact that that is the probability of any individual melon having a diameter greater than 135. Right? The probability that x, right, that variable I defined early on in part A, right, x was defined in part A, so now I'm using a new variable, y. The probability that x is greater than 135 is 0.345, so that's my probability of success for this binomial variable, this binomial situation of trying to figure out, hey, what's the probability I have at least 2 melons? So the probability that y is greater than or equal to 2. Okay. Once again, I have a fixed number of trials, 6. I have a fixed probability of success, 0.345. Right? Selecting the melons we'll assume is independent. Right? And either the melon has a diameter greater than 135 or it does not. So I'm looking for this probability y is greater than or equal to 2, which is simply 1 minus the probability y is less than or equal to 1. Using my table or using my calculator, right, for a binomial probability, I have 1 minus 0.329, which is 0.671. All right. So in essence, a little more than 2/3 of the time, a little bit more than 2/3 of the time, when I select 6 organic melons, I'll have at least 2 of them with the diameter greater than 135. And then the last piece for this question. determine the probability an SRS of 6 organic melons from distributor J will have an average diameter greater than 135 millimeters. All right, so I'm going to have an SRS of 6 melons from distributor J. So I'm going to grab my 6 melons, and I want to know that mean is going to be greater than 135, the mean of all 6 melons. So pause the video, try the work. Unpause when you're ready to check. So for this situation, we're looking at Y bar, right? If Y is going to represent my selecting 6 and having it be binomial where it's either greater than 135 or not, I can say Y bar. And Y bar is going to be normally distributed with mu of Y bar being 133, right? Centered at my population mean. And sigma of Y bar is going to be 5 divided by root 6, right? Sigma of the population divided by the square root of the sample size. So I'm looking for the probability that Y bar is greater than 135. I want the average mean to be more than 135. And that's going to be 1 minus the probability Y bar less than or equal to 135 using my normal CDF on my calculator or using my normal table. I'll get to these values. Okay. Now notice this is a small sample size. However, since the population was normal, our sample distribution of our sample mean will also be normal. Central limit theorem does not apply here. Right? I don't have to worry about the large sample condition. I already have a normal sample because I come from a normal population. So notice, though, that this particular question, where it was derived from, we did add a few extra pieces to ensure that you have an understanding of what you should be doing and not just developing your skills on finding answers that are available on other sources. Okay, so next video, we'll talk about another particular problem.